So in the first part of this question, I'm asked to simplify m to the 3 multiplied by m to the 4 here. So initially here, I've noticed that we're working with indices. We're working with two lots of m raised to different powers, and we're going to be multiplying them together. So if I'm thinking back to my laws of indices, and we're multiplying two different values together, I'm instantly thinking here of an example such as x to the a multiplied by x to the b. Now what we do here is we take the powers and we can add them together. So this would leave a result of x to the a plus b. Now this is a law of indices, so when we have two lots of m to different powers, we can simply add the powers together. So in this case we have, following the same principle, m to the power of 3 plus 4 gives us an answer of m to the power of 7, which I can put in here, as that's a fully simplified answer to this question. So now in this part of the question, we're asked to simplify this expression here. So 5 lots of np cubed, and then that whole bracket is going to be cubed. And we need to look at how we're going to simplify this. So in effect, this bracket that we have here is the same as writing out 5 multiplied by n multiplied by p cubed, and then that whole thing's going to be cubed. Sometimes it helps to look at it that way, just so we make sure that we know that we're not adding or subtracting any terms like this. So to cube this bracket, I basically have to cube each of the individual terms. So I'm going to raise each term to the power of 3. So if I start with the 5 here, I can raise the 5 to the power of 3. So 5 to the power of 3, and that's going to be multiplied by this n in the bracket raised to the power of 3. So multiplied by n to the power of 3, multiplied by, finally, p to the power of 3 to the power of 3 again. So p to the power of 3 to the power of 3. Now, similarly to the previous part of the question, I've got p to the power of 3. I'm raising it to the power of 3. This is going to require some knowledge of indices laws again. So if we have x to the power of a, and we're raising that to the power of b, this is going to give us an answer of x raised to the power of ab. So a multiplied by b is going to give us the power here. So in this case, when we have p to the 3 to the 3, we're going to do p to the power of 3 multiplied by 3 gives us p to the power of 9. So we have 5 to the power of 3 multiplied by n cubed multiplied by p to the power of 9. And we can rewrite that, so we have 5 cubed gives us 125. N cubed is as simplified as it can get. We can just write n cubed down. And then we finally have p to the power of 9. And these are all going to be multiplied together, so we can just write them together as one expression as 125 n cubed p to the power of 9. And that gains us both of the marks here. So the first mark would have been for 2 of the correct terms in this product, and then the second mark is for this fully correct answer. And then finally here, we're asked to simplify 32 lots of q to the 9 r to the 4, and that's all going to be over 4 lots of q cubed r. So we're working with a bit more of a complex expression here that we're looking to simplify. We have a quotient, so we have a fraction, so there's going to be some kind of division involved here. And just to make it a bit easier for us, I'm going to start by writing this fraction out in a bit of a nicer form. So the terms in the numerator and denominator, they're all multiplied together. So we have 32 multiplied by q to the 9 multiplied by r to the 4 here. So that's going to be useful to work with. I could rewrite this fraction. I could write it as 32 multiplied by q to the 9 multiplied by r to the 4 all over 4 multiplied by q to the 3r, so times r. And then, because we're multiplying all of the numerators and the denominators, the terms in each of those, we can simplify this again just so it's a bit easier to work with. So if I separate the numbers, so the integers here, we can take 32 over 4, and we can leave that as its own fraction. we can multiply this fraction by q to the 9 over q to the 3 to keep the q terms together, and then multiply that fraction by r to the 4 over r. Now this shows how we're going to work with the fraction. We didn't have to write it out like this to understand what we're going to do with the terms, but it is useful to kind of see how it looks and how we're working with it. So now I can simply take all of these fractions, simplify them and multiply them back together. And I can start with 32 over 4. That just gives me an answer of 8. And then we're multiplying that by q to the 9 over q to the 3. So here, again, I'm going to be referring back to my laws of indices. So for example, if I had x to the a over x to the b, so when we have the same sort of variable raised to two different powers, one over the other, this gives us an answer of x to the a minus b. So to find the new power, we subtract the denominator power from the numerator power. So here, working with the q's again, I can take q to the power of 9 minus 3 here. And then I need to multiply that by r to the power of, by the same principle, 4 minus 1. So we now have 8 multiplied by q to the power of 6 multiplied by r cubed. And because we're multiplying these together, we can just write them out next to each other. So the final answer here is 8q to the 6 r cubed. And we would get 1 mark for getting 2 of these terms right, and then the second mark for having the fully correct answer that we have here.